Hello everyone, this is the solution for problem 1 in homework 3. So firstly, we know that the probability density function of a variable x is px equals k equals the constant b times k of p to k minus 1. So firstly, we want to find the b such that the px equals k is a probability mass function. So by the property of the probability distribution, we know that the conditional density function tends to 1 when x tends to infinity. So it is f infinity equals 1. So it is equal to the sum of k from 1 to infinity, px equals k equals 1. So we know that b k from 1 to infinity, k p k minus 1 equals 1. So it is easy to know that k times p to the power of k minus 1 is the is pk, the gradient of pk. So it is, by change the order of the gradient and the sum, we know that. Therefore, b times 1 minus p, or p over 1 minus p equals 1. So that we know that b times 1 over 1 minus p power, the square of 1 minus p equals 1. So therefore b is equal to 1 minus p, the square of 1 minus p. So now we get the value of the constant b, such as the px equals k is a probability distribution. So next we want to find the expected value of variable x. So by the definition of the expectation, we know that the expectation of variable x equals sum of k equals 1 to infinity k times p, the probability of variable x equals k. So this is the definition of the expected value. So by the definition, we know that, sorry for that, one minus p, the square of 1 minus p times sum of k from 1 to infinity, k square p k minus 1, p to k minus 1. So it is equal to 1 minus p square, sum of k equals 1 to infinity, k plus 1 times k times p k minus 1 minus k equals 1 to infinity, k p k minus 1. So we already know the value of this part from the answer of A. So from this part, this is the second order differentiation of p to k plus 1. So it is 1 minus p square, sum of k equals 1 to infinity, p to the power of k plus 1. The second order differentiate minus k equals 1 to infinity, pk. So it is 1 minus p squared sum of, it is 1 minus p square, second order gradient, minus 1 minus p gradient. So firstly, we want to know the value of this part. So the gradient of p squared minus over 1 minus p is 1 minus p squared. The gradient of p squared is 2p times 1 minus p. Minus p squared times minus 1. So it is negative 1. So it is 1 minus p squared. So this is 2p minus p squared. So the second order gradient of this expression is minus p squared 2 minus 2p times, so it is power of 4. So 1 minus p squared minus 2, p2 minus p times 2 minus 1 minus p. This is plus. So it is the power of 4 to 1 minus p, the power of 3 plus 2p 1 minus p times 2 minus p. So it is 1 minus p, the cubic of 1 minus p. 1 minus p. So it is 2 1 plus p squared minus 2p plus 4p plus 2p minus p squared. Yes, this is 1 minus p cubic over 2. So therefore, we know that the value of this part. So therefore, the expected value of random variable x is equal to 1 minus p squared times 1 minus p cubic over 2 minus, so this is minus 1 minus p squared over 1. So this is 2 over 1 minus p plus minus 1. So this is 1 plus p over 1 minus p. So now we got the expectation of variable x. So for C part, we want the expectation of x squared. So similar to the solution of problem B, we got that it is equal to k equals 1 to infinity k squared. The probability of x equals k. So it is equal to 1 minus p squared times the sum of k from 1 to infinity, cubic k of p, k minus 1, p to k minus 1. So similar to the construction in problem B, we also want to have a gradient of a function. So it is 1 minus p squared, sum of k equals 1 to infinity, k plus 2 times k plus 1 times k p to the power of k minus 1 minus 3 times k equals 1 to infinity k squared pk minus 1 minus 2 sum of k equals 1 to infinity k times p to the power of k minus 1. So this part and this part is computed above. So now we want to know the value of this part. So it is equal to 1 minus p squared times third order of differentiate. So it is sum of k equals 1 to infinity pk plus 2 the third order of gradient minus 3 times 1 minus p cubic 1 plus p minus 2 times 1 minus p squared 1 over 1 minus p squared. So what we want to know is this part, the third order gradient of this function. So this is equal to 1 minus p to the power of 3. So therefore 1 minus p to the power of 3 gradient equals 1 minus p squared 3 p squared times 1 minus p plus cubic of p. So this is equal to, from a simpler simplification of the formula, we got that this is 2 p cubic of p minus 6 times square of p plus 6p. So therefore the second order is 1 minus p to the 6. So this is 6 p 6p 1 minus p. So the gradient of the dominant, it is 6p times 1 minus p times 1 minus p cubic. So this is not cubic, this is square. Minus so sorry. This is 3p squared minus 2p to the cubic, this part. So this is p times 3p minus 2 the p squared 3 minus 2p times 2 1 minus p plus. So this is equal to 1 minus p to the power of 3 2p cubic of p minus 6 power of p plus 6p. So the third order differentiate of the function is 1 minus p to the power of 6. So this is 6 1 minus p squared times 1 minus cubic of 1 minus p plus 2p p squared minus 3p plus 3 times 3 1 minus p squared. So it is equal to 1 minus p to the power of 4 6 1 minus p cubic plus 6 p squared minus 3p plus 3. So by simplification, we know that it is 6. This part is a constant 6. 6 over 1 minus p to the power of 4. So now we get the third order gradient, so we can get the value of the expectation of square of random variable x squared is 1 minus p squared times 1 minus p to the power of 4 over 6 minus 3 times 1 minus p. This is 1 plus p minus 2 times 1 over 1 minus p squared. So it is 1 minus p squared 6 plus minus 3 1 minus p minus 2. Also this is 1 plus p. So by simplification, we know that it is equal to 1 minus p squared minus plus 4p plus 1. So we get the value of the expectation of square of the random variable. So in D part, we want the variance of x, so it is equal to the expectation of the square of random variable minus the square of the expectation of the random variable. So it is equal to 1 minus p squared plus 4p plus 1 minus 1 plus p over 1 minus p squared. So it is equal to 1 minus p squared plus 4p plus 1 minus p squared minus 1 minus 2p. So it is 1 minus p squared 2p. So now I get the variance. In the last part, we want to get the conditional probability of x equals k when x is larger than 2 and smaller than 5. So by the definition of conditional probability, we know that it is equal to px equals k at the same time x larger than 2 and smaller than 5 over px larger than 2 smaller than 5. So this part is easy to know if k is larger than 2 and smaller than 5, so this is directly px equals k. But if k is not between 2 and 5, then it will become 0. So it should be px larger than 2 and smaller than 5 over px equals k if k larger than 2 and smaller than 5. Otherwise, it is 0. So now we want to get the value of this probability. So it is px larger than 2 and smaller 5 is equal to p the sum of k from 2 to 5. The probability of x equals k. So it is sum of k equals to 5 or minus p squared times k minus 1. So 1p is equal to 1 over 3. So this part is 9 over 4. Right. So this is 9 over 4. Sum of k equals 2 to 5. k minus 1. So this is 1 over 3 k minus 1. So by simplification, we know that it is approximate 0.5377. So therefore, we can conclude that the conditional density function is 0.5377 over b is 1 minus p squared, so it is 9 over 4 k times 1 over 3 to the power of k minus 1 if k larger than 2 and smaller than 5. Otherwise, the probability is 0. So this is the solution for the first part.